Right now, as you're watching this, trillions of your cells are making a decision: repair themselves or fall apart. There's an ancient system buried inside your biology that controls which one happens, and most people have no idea it even exists. It's called autophagy. The word literally translates to self-eating, which sounds terrifying, but it's actually the opposite. Picture a crew of molecular recyclers moving through every cell in your body, identifying broken parts, dissolving them, and turning the raw material into brand new cellular machinery. It's destruction and creation happening simultaneously, and it is one of the most elegant survival tools evolution has ever produced. For most of medical history, nobody paid attention to this process. Cells seemed to just work. But then, a Japanese cell biologist named Yoshinori Osumi changed everything. He was studying yeast cells in his lab, starving them of nutrients, when he witnessed something no one had properly documented before. Tiny bubble-like structures inside the cells started swallowing their own damaged components. The cells were literally digesting themselves to stay alive. That discovery earned Osumi the Nobel Prize in 2016, and it cracked open an entirely new field of longevity research. Because here's what scientists realized next. Human cells do the exact same thing, and you can switch this system on deliberately by simply not eating for a specific period of time. So the million-dollar question becomes, how many hours without food does it actually take before your body flips that switch? The answer is more layered than any headline will tell you, and understanding the full timeline changes the way you think about food, aging, and your own biology. Let's walk through what happens inside your body hour by hour once you stop eating. In the first 0 to 6 hours after your last meal, honestly, not much changes on a cellular level. Your bloodstream is still flooded with glucose from whatever you ate. Insulin is elevated, doing its job of shuttling that sugar into your muscles and liver for storage. Your cells are comfortable. They have no reason to activate emergency repair protocols when the pantry is fully stocked. You might not even feel hungry yet. Between 6 and 12 hours, a quiet shift begins. Your liver starts burning through its glycogen reserves, which are essentially your body's short-term fuel tank. Insulin levels drop noticeably. Your system begins transitioning from running on sugar to tapping into stored fat. Hormones like norepinephrine tick upward, keeping you mentally sharp even though calories have stopped coming in. Growth hormone starts climbing too, which helps preserve your lean tissue during this transition. Your body is clearly preparing for something, but the cellular cleanup crews are still on standby. The conditions are forming, but autophagy has not truly begun. Now, somewhere past the 12-hour mark is where things start getting genuinely interesting. Glycogen is running low, insulin stays suppressed, and deep inside your cells, molecular sensors called AMPK and sirtuins detect that resources are becoming scarce. These sensors function like biological alarm systems. When they activate, they send a signal that essentially tells your cells to stop building and start repairing. Growth pathways like mTOR get dialed down, and maintenance mode takes over. Your body is shifting its entire priority from expansion to preservation. Think of it like a company freezing all new projects to focus entirely on fixing infrastructure. At this point, autophagy is beginning to stir, but it hasn't reached full force yet. That comes next. Around 16 hours without food, the recycling machinery kicks into a higher gear. Specialized structures called autophagosomes start forming inside your cells. These are like tiny biological stomachs that engulf damaged proteins, broken down enzymes, and malfunctioning mitochondria, then dissolve them into reusable parts. Inflammation markers begin to drop. Antioxidant defenses ramp up. Your brain may start to feel unusually clear because blood sugar has stabilized, and your body is producing a compound called BDNF, brain-derived neurotrophic factor, which supports focus, memory, and learning. This is the stage where many people doing a standard 16-8 intermittent fast are tapping into mild autophagy on a daily basis. It's real, it's measurable, and it accumulates over time. But the deeper transformation requires more patience. At 24 hours, your body enters what researchers often describe as the repair zone. Glycogen is essentially depleted. Fat metabolism is fully dominant, and a specialized form of autophagy called mitophagy becomes highly active, specifically targeting damaged mitochondria, which are the energy factories inside every cell. When those factories malfunction, they leak harmful molecules that accelerate aging and fuel chronic disease. Clearing them out is one of the most significant things your body can do for long-term health. Studies also show that around this window, the immune system begins a partial regeneration, recycling old white blood cells and stimulating the creation of fresh ones. It's a genuine biological reset happening beneath the surface. Extending the fast to around 36 hours pushes autophagy toward its peak intensity. Research in cell biology and longevity science points to this window as something of a sweet spot, where cellular recycling operates at maximum efficiency, before the body risks tipping into genuine deprivation. Growth hormone can surge up to 5 times its baseline level, protecting muscle while your system burns fat and recycles damaged tissue. The combination of deep autophagy and elevated growth hormone creates a powerful metabolic environment that many longevity researchers find remarkably promising. But here is where honesty matters more than hype. Fasting beyond this point without medical guidance starts carrying real risks. Cortisol rises, muscle breakdown accelerates, hunger hormones spike aggressively. The body stops performing strategic repairs and starts cannibalizing healthy tissue just to keep the lights on. There is a critical difference between controlled fasting and starvation. Fasting is voluntary, time-limited, and designed to trigger repair. Starvation is prolonged deprivation where systems begin to collapse. One builds resilience, the other destroys it. The line between them is thinner than most people realize, and respecting that line is what separates a smart health practice from a dangerous one. What makes this even more fascinating is that fasting is not the only way to activate these pathways. Intense exercise temporarily depletes glycogen and triggers AMPK, mimicking a fasting state at the cellular level. Compounds like the polyphenols found in green tea, turmeric, and certain berries activate those same energy-sensing pathways. Deep, consistent sleep gives your body uninterrupted hours for cellular maintenance and hormonal repair. Even moderate calorie restriction without full fasting can nudge autophagy into low-level activity over time. So, while fasting remains the most direct and powerful trigger, your daily habits create a foundation that either supports or undermines your body's ability to clean house. So here's the practical takeaway from all of this science. Most researchers agree that meaningful autophagy begins somewhere between 16 and 36 hours of fasting. A daily 16-8 routine keeps your cells regularly maintained. An occasional 24-hour fast provides a deeper level of repair. And for those who are experienced and medically cleared, a 36-hour fast can deliver something close to a full cellular reboot. The real power, though, is not in any single fast. It's in the rhythm. The more consistently your body enters and exits this repair state, the better it becomes at protecting itself, clearing damage, and renewing from within. So the next time you feel that familiar pang of hunger and consider reaching for a snack, remember this. That discomfort might actually be the sound of your cells gearing up to heal themselves. If this changed the way you think about fasting, hit subscribe so you don't miss the next deep dive. I'll see you in the next one.